Hi, everybody. We're going to do chapter 5 of the NQF4 PDE 4 examination file. The chapter is statistics. The content of the chapter is a bit too much, so I'm going to split the chapter in two, in section 1 and section 2. This recording will deal with section 1, and we're going to go through everything step by step. So I want you to take a deep breath and just follow me. If there's questions, you can WhatsApp me or you can email me. I'm going to share my screen with you, and we're going to go through the module together. Okay. I'm going to first stop my recording. Then I'm going to share my screen with you. I just want to share my total screen, my entire screen, and I say share. There we go. And I'm going to upload the document. There we are. This is chapter 5, and we are at section 1. The whole chapter 5 is statistics, and we're going to look at collecting, organizing, and representing data. Okay. This is just your specific outcome. By the end of this section, you will know how to collect data, organize data, use different representations of data, and use statistical measurements. Okay. First of all, to collect data. Okay. Data is just a word in statistics, which means information, okay, that can be quantified. You can link a numerical value to the data, to the information, okay? Now, society depends a great deal on the answers that you get from collection and analyzing data, which is obviously statistics. And people analyze the data to obtain this information. Okay. Now, misuse of statistics is quite a phenomenon because statistics can affect social policy, medical practice, and the reliability of structures. So you need to have a basic set of statistical skills. You need to have skepticism to question your findings and see if the findings is reliable. Okay, so statistical literacy, I marked all the new terms for you and highlighted in pink. Statistical literacy is statistical data that you can control. For example, the number of people on pension, you can control that. You can type a different value in there, okay? There's other measurements that you can't control, okay? It's like if you want to know how effective your advertising campaign was for a new development, you can't simply just count the numbers, okay? So what will you count? You will count people's opinions. That's something totally different, okay? Sampling is another definition. It's a small group of people and you use a survey to ask them questions, okay? But that sampling is a small group of people. And with that sampling, you try to represent the whole population, okay? So your population in statistics is not really a country, but it's referring to members of a certain group. So let's say we do a statistic analysis on your advertisement for your new development. Our population group is going to be, let's say, people under the age of 40 with a certain income group, okay? That will be your target group. So that will be your population and your Your target group might be more specific. They must have children. They must be from a specific gender, socio-economical group, or combination. You have your population, and then you can define it smaller into the target group. Okay. Members of a sample, or let's say people who's completing your survey, is respondents because they respond to a survey. Okay. We all know what a survey is. It's a series of questions designed around a specific issue or product. So this is just, again, definitions. I marked it for you, and I marked the answers in yellow. It's good that you also mark that in your file and that you know the definitions, because you can definitely get these. Let's say a survey has a representative sample of 20 members, and 7 out of them were found to use product A. We can say it is inferred, and the other word for inferred is extrapolated, that 7 out of 20 people in South Africa use product A. Okay. Now, I actually typed in additional notes for you to make it easier. Extrapolating means to use available data or information to make inferences or predictions about what might happen or what something might mean in a broader context. Okay, so that just makes that term, it clarifies it a bit more. Okay. This is known as extrapolating the data to the whole population, because if you can see, we said 7 out of 20 people in South Africa use product A. Our representative sample was 20 members, and 7 of them found to use product A. So we're extrapolating the data to the whole population. Okay, so that's what that means. Sample groups are not always the same size, okay? And statisticians use different methods to determine the optimum size of samples, okay? If we move on, we're going to quickly discuss inductive and deductive statistics. I also made additional notes here. Inductive statistics is analyzing data without making any assumptions. You collect the data, analyze the data, and then you draw conclusions based on patterns and trends in the data set. Okay. Deductive statistics is you draw a conclusion from the data about a population based on the data. So I also highlighted it for you in pink. Just know the terms: inductive, deductive. Okay. Then we move on to survey questions. We get open-ended and close-ended questions, okay? Open-ended questions, you can have a variety of possible answers. How do you feel about global warming? So you want the person or the respondent to give you insight, okay? Close-ended questions have a finite set of answers, okay, from which the respondent choose. It's close-ended questions is easy to standardize, and close-ended questions are also more difficult to write than open-ended questions. Now, your statistics is going to focus on your closed-ended questions. I made additional notes here again, if we can go through it. Closed-ended questions limit the respondent's range of possible answers. And it does not encourage elaboration or discussions. Example, did you enjoy the movie? Have you ever traveled to Europe? What is your age? So what's your age? 40. Okay, have you ever traveled to Europe? Yes. Okay, did you enjoy the movie? Yes. Okay, it's often used in surveys. Answers can be easily categorized and analyzed, and it's usable or very useful to obtain quantifiable data. Quantifiable data can be expressed numerically or in a measurable form. So quantifiable data can be measured. Okay, so this is just to add on to the close-ended questions. Okay, now there are 5 types of close-ended questions. Now, this is where we get to the statistics, okay? The Likert scale. Here's an example. from 1 to 5, okay, it's always, they use it often to show agreement or disagreement with a certain statement, okay? Let's say 1 is not very important, where 5 is extremely important, okay? Then you will say, did you enjoy, let's say, how do you think, how important do you think eating a good breakfast is, okay, to a businessman? Is it important or not important? So you will use the Likert scale as a measurement. Then you have your multiple choices, where you choose A, B, C, D, or E. You're going to get multiple choices in your PDE exam. Okay, so we're all familiar with that. Then we move to our ordinal, okay, our ordinal measurements, okay. Ordinal numbers are used to show rankings, okay. So you're going to, normally in the question, they ask you, choose a number between 1 and 5 to describe the item below. 1 is most important, 5 is least important. Now, the difference between, just want to say, stay in the call, sorry. I just want to go there. Okay. The difference between ordinal and what was it? Likert scale is Likert scale is always used or more often used in to show disagreement, agreement or disagreement with a certain statement or question. Where ordinal is how did you find the quality of food, the quality of service? So you don't agree or disagree. You just basically indicate a ranking. You show a ranking of the service, okay? Then you get your categorical data. That is data that consists of categories or groups, and your respondent must place him or herself in the category. You will, like, how do you see yourself? Like a total introvert, extrovert, neither? Then you just choose, this is categorical. Then numerical is real numbers, like how old are you? How many children do you have? How many years ago did you, when last did you go on holiday? How many years? So this is numerical. So it's very important that you familiarize yourself with these data, categorical, numerical. And then on page 265, you have your type of question, your open-ended, closed-ended, Likert scale, multiple choice, ordinal, categorical, and numerical. And there they summarized it for you, which I highlighted. Open-ended, you use it for breaking ice in an interview. Your own words is important. And the surveyor don't know the possible answers, the researcher. Close-ended, it's quantitative. So this is more statistical results that you're going to get. The Likert scales assess your feelings about something. Multiple choice, we're all familiar with that. Ordinal, to rate things in relation to other things. Categorical is categorize yourself. Numerical is real numbers, okay? Now we're going to discuss bias in surveys. You get your sampling bias. It's tendency of sample statistics to systematically overestimate or underestimate the population parameter. Bias due to unrepresentative samples. A good sample is always a representative sample. Bias often occurs when the survey sample does not accurately represent the population, okay? Or if you haven't selected the population for your research properly, okay? Under coverage, you get then selection bias. Under coverage and over, under coverage is when members of the population are only inadequately represented in the sample. So basically, your population is not reflected in your sample as a whole, okay? Then you get convenience sampling, okay, which you can get from telephone directories and car registration lists. This is also a bit of a sample or selection bias. Because it doesn't really reflect, it's convenience sampling. So a lot of errors can come from there. Undercoverage is often a problem with convenience samples. Okay, so you have to be familiar with the terms. Okay, a non-response bias is when the respondents differ in meaningful ways. Okay, from non-respondents. Okay. This is if your individuals that you chose for the sample are unwilling or unable to participate in the survey. You get voluntary response bias is when sample members are self-selected volunteers, and then they can answer your questions in a specific way, and that's bias. That's voluntary response bias. Random sampling is a procedure for sampling. Okay, it's a selection of a sample based on chance. It doesn't really describe it very well there. I just added a note. A random sampling is when each member of the population has an equal chance of being selected. Okay, this eliminates bias most of the times. Okay. Then bias due to measurement errors. Poor measurement process. A poor measurement process can lead to bias. This is why we do this statistics. Okay. You will always have to look at the environment in which the survey is conducted, the way the questions are asked, and the state of the survey respondent. Are they in a good state? Because the state they are, your respondent can influence your results. Okay. Response bias refers to the bias that results from problems in the measurement process. Okay. So you can, in your survey, you can use leading questions, which is bias. Okay. You might favor one response over another. For example, a satisfaction survey may ask the respondent to indicate whether he or she is satisfied, dissatisfied, or very dissatisfied. This is bias because the option to express dissatisfaction, okay, has two. So you should have satisfied, very satisfied, dissatisfied, or very dissatisfied to make it unbiased. Okay. So the option to express satisfaction and two responses for option to express dissatisfaction. Okay. So the survey question is biased toward getting a dissatisfied response. Then you have social desirability. Most people like to present themselves in a favorable light. So if they answer your survey, the questions might not be accurate. They might answer your question in what they believe should be the right answer. That's social desirability. So all these terms that I highlighted for you is extremely important. You need to know the definitions because you might get questions on that. Okay. Now we're going to discuss sampling error and survey bias. Okay. Normally, if you do a survey, you have to measure the outcome repeatedly. Okay. You can use different samples each time on the same survey. You will get a different result, but if you replicate it more and more and more, your answers should be more or less the same. Okay. If the statistics is unbiased, the average of all the statistics from all possible samples will be equal. So if you do a research study and you can't replicate the study, it's not a good practice. Okay. Sampling error is the variability among statistics from different samples. So if you can't, let's say you replicate your study and your variability among the statistics differ. It's sampling error. Okay. Increasing the sample size tend to reduce sampling error. Okay. Increasing the sample size does not affect survey bias. A large sample size cannot correct for the problems of undercoverage or non-responsive bias to produce survey bias. Okay, so this is just the different terms. Now we're going to start with the actual statistics. Now we're going to look at organizing your data. Now remember, we said data is just information. It's another word for information. Data consists of numbers. This is now in statistics, okay? Data that has not been organized will be raw data, okay? Raw data can be arranged in various ways. It can be ascending, descending, or it can be in different categories called classes, okay? The number of items in a class is called the class frequency. A table of data arranged in classes with corresponding frequencies is a class frequency, okay? That is a class frequency is the number of the items in the class. Okay, a frequency table is a table of data arranged in classes with corresponding frequencies or numbers. Frequency tables, okay, now let's say you want to find out in your feeding area the number of families in your area having children of junior primary age. You want to look at what the monthly income is of each family, the number of children aged between 6 and 9, the number of children who attend school, okay? Now, suppose you ask 124 families to complete a questionnaire. Your sample size will be 124 because you're going to ask 124 families, okay? This is going to be an inductive exercise. Now, I made a note here. Inductive is you're going to draw a conclusion based on specific observation in the data, okay? Now, let's say they gave us the details here of the data set. Okay. I just want us to go through this table that we can understand. For the purpose of this exercise, I is the income per family per month and expressed in rand. Then NF is the number of families in each income group. NP is the number of junior primary age children. NP, there you can see, is the number of junior primary age children attending school. That's NP plus. NP point is the number of junior primary age children not attending school. Okay. Now in the smaller than 500 column, okay, there are 12 families, okay. Then we have 72 children at junior primary age. We have 37 that goes to school and 35 that does not go to school, okay. Then the pattern is repeated across your scale over there from 500 to 1,000, 1,001 to 1,500, okay. Now, let's say you want to analyze the group further and find out the ages of the children who do not attend school, okay? So X is going to be your number of children. So X is the number of children not attending school, okay? Age is X and the N is the number of children not attending school, sorry. So we're going to go down further. There we go. X is your age, okay, because we do have the ages, 6, 7, 8, and 9. Just want to check. We had our ages here. Just want to check 6, 7, 8, 9. No, we did not. Okay, they gave you the ages here. Okay, so a table showing both class X and N. These are the ages, and then the N is 9. All children in total is 99. You can see it adds up with your total children, 99. Oh, here you can see your children. NP was the number of junior primary age children not attending school. So there you can see 35, 20. Yes, we got 39. I just want to see where we got that from. No, they didn't work it out like that. Okay. So they gave you N. The number and ages of children not attending school in the area is clear. 39 6-year-olds. Okay. 27 7-year-olds, 21 8-year-olds, 12 9-year-olds. And it's a total of 99 children that does not attend school. I just want to see if we add it up here. Yeah, this is the total. NP not attending school, 100%. Okay, so there you can add it up. That 99 should add up over there. Okay. Now we're going to check that the numbers correspond with the data we have. The new data using ages must display the same result, and it does. 39, there you can check where we got that from, okay? The data used in this exercise are called discrete data because the data has exact values, okay? Discrete data is data with exact values, okay? What they might do in the exam is they're going to ask you how many 8-year-olds is there that don't attend school. Then you will need to know X is the age and N is the number of children that does not attend school. So you need to know, this is the rationale for the exercise. You need to know how to read this table, okay? Some data is difficult to tabulate because they are so varied, okay? That is what you call continuous data, okay? Frequency tables using continuous data must be set up differently. For these data, you use a group frequency distribution in which classes have a specific class width and class limits. If we look at group frequency tables, I just want to make my screen a bit smaller. I'm going to do, okay. Then, okay, your group frequency tables, they will give you the data in the exam, okay? Now, find the lowest and the highest value. Now, I already marked that for you. It's 23.2 degrees, and then 31.1 is the highest, okay? Choose the class limits and determine the classes. Now, there will be 8 classes. Okay, the upper limit of each class will depend on the width. Now, I want to see why they say, oh, there's 8 classes because if you look at the various degrees over here, there's only 8 of them, okay? If you look, the first class will hold a range of temperature between 32.2 Celsius and 24.1. Let me just quickly see how I got to this. You have your lower and your upper limit and your lower limit. Okay. Let me just go down here. So there's your classes. The frequency of the data. Count the total number of times a temperature occurs in each class, okay? This is now your different temperatures, okay? So here you have your different temperatures. You're going to count them and put them in different classes. And then you have 8 different classes with your temperatures, okay? So there you can see it's 1, 2, 3, 4, 5, 6, 7, 8. Then you can count the number, how many times the temperature occurred in this table, okay? And you can see it there, okay, where your number is. That is the frequency of the data, an N, which is the value or the number, a numerical value, how many times they occurred, the frequency they occurred in the temperatures. Okay, so that basically describes that. If you add all these numbers up, you're going to get to 28. Okay, because I hope it makes sense. This is all your temperatures. There is 28 days. Okay, if you add all this up, you should get to your 28 days. Please do activity 1.2. It's good that you familiarize yourself with the content. If you want me to review your answers, you're more than welcome to send it through to me. Now we're going to move on to representing the data. Pictograms is another definition where pictures are used to represent the data. And it's a simple, easy way of representing information. Now, let's say they're going to ask you, how many members did the chess club, for instance, have? Okay, was it 13 or 14? Now, we look at our key here. One little man stands for 4 members. There's 3 members and a half, okay? So we're looking at 3 members and it's 4, okay? That equals 2 plus the half man, 2, it equals 14. So there's your answer. Okay, work it back and see if you understand what I say. But it's 3.5 men, okay? 3 men equals 12 because the value of 1 man is 4. So 3 times 4 is 12. And then there's another half one. So if 1 man stands for 4, you divide it by 2, it's 2, so it equals 14. So it's 12 plus 2 is 14. We're going to move to pie graphs. A pie graph is also called a pie chart. They are so named because they resemble pies. The slice of the pie represents different percentages. Drawing accurate pie graphs require data to be transformed into percentages so that the size of the wedges, also called sectors, can be calculated. This is quite important. You're also going to get something out, something of pie charts in your exam. I actually marked it for you with an exclamation. So if you see a pie chart, you must know it must always be in percentages. Now I made notes here for you. Change percentage into a numerical number because they might ask you, if there were 1,000 participants in a survey and 27% of them liked comedy, this would be how do you calculate to change a percentage into a numerical number or numerical value? Then you take the 27%, you divide it by 100. You times it by the 1,000 participants and you get 270 people. You have to make a note in your file. This is the sum to change percentage into a value, okay? If you want to reverse the process, okay, to change the data to change a numerical number into percentage, you're going to get your 80 people, okay, out of 1,000. So you're going to take 80 and you're going to divide it by 1,000, okay? Then you're going to times it with 100. Then you will see it's 8%, okay? Or you can say, well, this is just another way of putting it. You're going to get your data, which is 80 people. You're going to divide it by 1,000 participants, and you're going to multiply it with 100. Okay. They might ask you, how do you draw a pie graph? You can say, first convert the data into percentages. That's so important. You know what? Estimate the size of the sectors and draw the graph. If you do it on a computer or Excel, for example, the computer does it automatically for you, okay? And in fact, it will convert the data into percentages as well, okay? Here we go. Now, let's say here is the number of ladies, and I marked it there for you. Okay, so you're going to get your percentages. Okay, and then 61, I just want to see. Okay, the total number of ladies attending the spree, that's the total number of ladies. So you have 10 ladies, okay, and you divide it by 61, which is the total number of ladies, and you multiply it with 100. There you have your 16.4%. Okay, this is just the exercise for you. Then bar graphs is just, you have to know what it is. It consists of vertical and horizontal columns. The height or the length of each column is proportional to the frequency of the data. And it's got information. It's got an information bar for you on the sides, okay? There is an exercise for you. Please do that. Exercise is always good. A line graph, here's an example. The axis of the line graphs are set up similarly to bar graphs, but the data is plotted as points and not as bars. And then the points are joined from the lines. Okay, then you get scattered plots, scattered diagrams, or scattered graphs. This kind of graph is used to calculate an equation which best fits the data. There we go. They asked you here in an activity, lines of best fit is trend lines. That's lines when you draw it to represent the data the best. This activity 1.4, I already draw the lines of the best fit. Read here why they say it's the best fit, because of your data points over there indicated your lines of best fit. Okay, that was activity 1.4. Then you get bell curves, but this is a bit more advanced, okay? Some data might lend itself to parabolic or hyperbolic curves. There you're going to look at the curves of the data, but I don't think this is on this level of statistics. Okay, then you can familiarize yourself with activity 1.4. You can conduct the activity and email me if you want me to review. Now we're going to look at statistical measurements. Now, I think this is very important out of the whole chapter. Statistics, in statistics, the average is very specific, and you get a median and a mode. Now, what do we mean with the median? Okay, you have your data set. The middle element of a data, in a set of data, organized from the smallest to the largest, is called the median. Now, if we look at the middle effect, okay, you have your set of data here, and we arrange them from the smallest to the largest. Then the set becomes all the letters. There was 1, 2, there was 3 threes, 4, 5, 6, 7, 8. Okay, if we look at the middle value, it's going to be 4. Okay, I marked it for you as well. So the median will be 4. Okay. Now, if we look at another exercise, the median is the middle. Okay. So if you have 5, 2, 7, 9, you're going to first categorize them from the smallest to the largest, like 2, 5, 7, 9. Your median will be 5 and 7, because 5 and 7 are both in the middle. Okay. If there was only 2, 5, 7, then 5 would have been the median. Okay. You can calculate the median further, the median would be calculated by adding these two values and dividing them by 2. So you can say 5 plus 7 divided by 2 equals 6. Now that is the median. So they might give you a letter 5279 and say, please provide the median for the following 5279. Now you're going to look at it, and then you're going to categorize it from the smallest value up to the largest value. Then you're going to get the median, the middle, okay, the two middle ones, okay, because they are in the middle, and you're going to add them together and divide them by 2. The median will be 6. Okay. Now, if we look at the mean, the average, okay, the average or mean is when the sum of all values are calculated and the answer is divided by the number of values. Okay, now we're going to look at this. Here's a data set, okay? They will provide you with a data set. Now, you can make the sum below is the example of the sum. If you look, the value of all of these numerical values, if you add them all up, they will be 69. That's where that 69 comes from, over there. Now, the quantity numerical numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is 11. That's the quantity numerical numbers. So that's where the 11 comes from. Okay. Now we're going to take the value and we're going to divide it by 11, which is the quantity of the numerical numbers. And we're going to get 6.27. So there I explained to you. So that is the mean, the average of the data set. Okay. And you definitely, I mark my words, you're going to get this. They're going to ask you the median and they're going to give you a data set. And they're going to ask you what is the mean of this data set, the average. Okay. So there is some explanation and a sum that you can understand, and over here as well. Now we're going to look at the mode. The mode is a value that occurs most frequently in a data set. Okay. So if you have a data set over here, what letters occurs frequently? I can see 2 and I can see 4. Okay, so there's no sum that you have to work out here. You just see what letters occurs frequently, and that's the mode. Now we're going to look at the arithmetic mean. Okay, now the arithmetic mean is exactly the same as the mean, except it's written in a special way. Okay, they use the sigma, or it's a Greek letter, which means sum. Okay. I don't think you're going to get a question like this, but you need to work it out in a sum. And I basically worked it out for you. Let's say you get a data set. You can use a calculator, but I don't. You're not going to use statistical calculators in the exam. You can work it out normally. That's how I guided you, with a normal calculator. So you have your data set. They can say if X is 3, 5, 8, 4, and 5, okay? Then you know there's 1, 2, 3, 4, 5 numerical quantity numbers. So there's 5. So I write here, numerical quantity is 5. The numerical value of this is 25 if you add them up. So this is how your sum look. 1 over 5 times your data over there. The value of your data is 25. Okay, so if you can look, it still stays the same because the numerical quantity is 5, but it's 1 times 25. So if you divide 25 by 5, you get 5. So your answer is 5. Just go through that and make sure that you are familiar with it. And that is an arithmetic mean. Here you use how you use your statistical calculator, but you can work it out on a normal calculator as well. Okay. I'm going to carry on here. A class midpoint is the center of a class. It's found by adding the upper and lower class limits and then dividing it by 2. Okay. So I'm going to look at this now. Okay. So if you look at this example that they give you, 2.4 plus 1.5, 2.4 plus 1.5 amounts to 3.9. Now, if you take 3.9 and you divide it by 2, you get 1.95. So that's the sum. That's the class midpoint of the two data sets there. Okay, so because we added it up and we divided it by 2. Okay, so the class midpoint for that two data sets will be 1.95. Also marked it because they might ask you that. If we look to, and now here's another example of arithmetic mean, is when you use group frequency data, you multiply the midpoint by the frequency for all data. You find the sum of these and then divide the answer by the sum of all frequencies. So here's your midpoints, okay? You multiply your midpoints by the frequency, okay, by 5. So you can see over here is 153 times 5. Then it's 158 times 18. So all these, okay, so you're going to get your totals over here, and it will amount to 16,375, okay? If you add your frequencies, it's going to add up to 100. This is where that 16,375 over 100 comes from. Now you're going to divide it. So your answer is 163.75. This is the arithmetic mean if you use grouped frequency data. They might ask you something like this. Go through this exercise with your calculator, get your total and see if you come out with the sum over here. Compare. Please do activity 1.7 and look for the mean, median, and mode and how you use that in different situations. Okay. Now, I actually gave indicative notes for you. If 5 members of a company each earns 7,800, 10,000, 7, 8, 13,000, and 25, would it be fair to say the best indicator of salaries is in the company is the mean, median, or mode? Okay. Now, first of all, we're going to look what the mean is. Now, they say the mean is 12,720. Why? Okay. Because the mean is the rand value, the total value of all these rand values that they gave you is 63,600. You're going to divide it by the rand earning indicators, which is 5. It's 1, 2, 3, 4, 5. Okay. That gives you 63,600 divided by 5 is 12,720. That is your mean. Okay. Your median, I clarified it for you. That is the middle element of the data, which is, now I'm going to, again, remember, if I do a median, I'm first going to categorize the data from little, so 7,800, then 10,000. So I categorize it numerically. I start at the smallest value and I end at the highest value. Now my middle is 10,000. There's only one because there's 2 sets of numerical indicators there and 2 sets of numerical indicators over there. So the middle, the median is 10,000. Okay. Then the mode is 7,800 because 7,800 occurs twice. So the frequency is more, okay? So 7,800. So I explained to you how I got to that. So the best indicator for the salary would be the mean, okay? Sorry, no, it would be the median, okay, which is 10,000, okay? Medians are less influenced by extremes in data than means, okay? So you will look at median for the salary. Measures of spread, we get range and then mean deviation. Now, your range is the length of the smallest interval which contains all the data, and it's calculated by subtracting the smallest element of data from the greatest and provides an indication how spread out the data is, okay? I want to quickly check for you. Okay, so if you get a set of data, there's your set of data, 2, 4, 6, 8, and 10. The range is then from 10, okay, because 10 is the highest, so it's the greatest element in the data, and you subtract it from the smallest element in the data. So you have your highest element, which is 10, and your smallest element is 2. You subtract it from each other and you have 8. In set B, okay, we will look at the highest element, which is 101, and the lowest, smallest, is 17. So 101 minus 17 is 84. That is our range. So the range in that data set will be 8. The range in the data set B will be 84, okay? So the range of B is far larger than A. The data in B are therefore more spread out than in A. So if it's larger, it's got a higher value, it's more spread out. The spreading out of this data is called statistical dispersion. Okay, now we're going to carry on. The deviation is the difference in the value of the data and the mean. Okay, now we have the deviation. Can be, okay, deviation, and it actually comes in here. I just want to go on. Deviation can be a value that's assigned to something. So it can be the first value in your data set, the second value in your data set, the third value, the fourth value. So that's your deviation, okay? The value in the set of data. So basically, to understand this deviation, we're going to have to look at the second exercise, then it will make more sense to you, okay? Consider set B above, okay? There's set B above with the data set, okay? We look at the first value is 100, okay? So the first value is 100, and the arithmetic mean for the data, okay, is 76.17. Okay, 76.17. Okay, I just want to see how I got to this. Okay, this is the numerical quantity. So the numerical quantity is 1, 2, 3, 4, 5, 6. There you have your numerical quantity. Your numerical value, if you add everything up, will be 457. Okay, so if we take the numerical value and we divided it by the numerical quantity, which is 6, we're going to get 76.17. There we go. Okay, that's the arithmetic mean. Okay, now if we look at the deviation, they can ask you deviation of x1 or x2 or x3. So x1 is the first value. If it was x2, it would have been the second value, but they're asking specifically now x1. So that is 100. Okay, so the first value set is 100 minus your arithmetic mean, which is 76.17. So your deviation would be 23.83. Your deviation of X1 in the data set is 23.83. I hope it makes sense. We're going to do another one. Okay, because the mean is an average of some of the answers will be larger than the mean and some will be smaller. You can even get a negative means. Some means, some deviations will be negative. That will be normal. Okay, so we're going to do another one. The mean deviation of a sum of all the individual deviations, ignoring negative signs, and then divided by the number of the value set. So here's the values that they provided you. Okay, now if we look at the mean deviation, okay, I just want to check here. This is what they did. Okay. 1, 2, 3, 4, 5, 6. Okay. Look at your data set and B. Okay. We did the sum with X1 was the first value set in the data. Now over here is your second set in the second value in the data set, your third value in the data set, your fourth value in the data set. So make a note and you can work all the individual deviations to see if you come out to the same value as what they do in the textbook. Then they added up all the individual deviations to get the mean deviation of set B. So individual deviation will be, okay, X1 is individual deviation can be X1, X2, X3, X4, X5, X6, okay? Then you basically take it. I just want to familiarize myself. The first value, and you subtract it from your arithmetic mean. So you get your first value, your second value, your third value, as indicated below. You deduct it from your arithmetic mean, and then you get your answer. You can see over there, X1 is 23.83. There it is, 23.83. Okay. Just to show you, if you work it all out, your individual deviations, if you add it all up, it will come to a 178.66. You're going to divide it by 6 because there's 6 individual deviations, and your mean deviation will be 13.11. It will be for that exercise. I hope it makes sense. So if it doesn't, you're welcome to communicate with me further. The mean deviation gives an idea about how the data are spread out. The smaller the mean deviation, the closer the data are. A large mean deviation tells us that many of the data elements are far from the mean. Okay, so the data will be more scattered. Here's another activity that you can do, 1.8, which is a good thing. And then I want you to look at the self-assessment questions as well. If you want me to review your self-assessment questions, please do so. Email them to me that I can review them. But yeah, I think that's it from me. In the next chapter, we're going to start with section 2. Okay. Sorry. Where we will look at probabilities. Okay, so I hope everything made sense. I just want to stop my screen sharing. Okay, so I hope everything makes sense. Make notes. If you have questions, please send me emails. If I must explain a term or a statistical calculation in more clarity, you're welcome to WhatsApp me and I will help you gladly. I will do the probabilities in the second presentation because I think this chapter is quite lengthy and it's very intense. So you have to review it not only once, you're going to have to review it like 2, 3, 4 times. Okay. Yeah, that's all from me. You must have a lovely day further and we'll speak soon.